So what we're going to cover today is basically AFM and then why it is a good option for you to use, whether you in aquariums or in aquaculture, and then all of its different applications. I am going to go pretty quickly because it's quite a lot we're going to cover in a short space of time, and I always prefer to have more questions and answer time than having in the presentation. So if you wouldn't mind, just to make sure the presentation runs quickly, is to hold off on the questions until the end. I'm always happy to jump back to a slide if you have a question on a particular slide, but let's cover the questions at the end so it doesn't slow down the whole progression of the presentation. As Ax was saying, Fresh by Design is our distributor in Australia for aquariums and aquaculture side. We work around the world. Sorry, let me click on that. There we go. So just a quick introduction of what AFM is and why it's good. Then we'll talk a little bit about the technical specifications and why it actually works as well as it does compared to any other medias around the world, and then the question and answer session. So if we look at just a very brief why AFM is really because biological resistance on the media prevents any biofouling happening in the media, and therefore as a filter media it never suffers from the channeling like sand does. So sand is the best surface for bacteria to colonize, and once bacteria settles onto a surface it creates these clumps, and once you start getting clumping you get the channeling through your filter bed. The AFM, because it doesn't allow the bacteria to settle on the surface, it never clumps like sand does. Second of all is because we can achieve 1 micron filtration at 20 meters per hour, so 20 cubic meters per hour per square meter with the filter media, whereas sand generally only gets to around about 20 microns, right? When it starts to become biofouled, it can get lower than that, but then also your channeling events and your disruptions. So when your filter actually bypasses, creates a channel, bypasses unfiltered water through the filter bed and out the other side, and then that channel collapses, becomes more and more frequent as your filter becomes more and more biofouled. If we then also do coagulation flocculation, which we quite often do with seawater intake systems or with wastewater treatment, we can actually achieve a filtration of 0.1 microns, right? So we're not filtering 0.1 micron particles, but with coagulation flocculation, we're bringing those particles together to a size that's bigger than 1 micron, and then we're filtering those out. I'll speak a little bit more about how we filter down to 1 microns in the next couple of slides. The most important thing, and people always forget this when they're using media filtration, is not only how well your filter filters, but how well your media backwashes as well. Because unless you are backwashing your media correctly to release all of the dirt, your filter will always build up with debris over time, right? Sand is very well known to only, even at the best backwash performance using aeration, to only release about 70% of the dirt caught in the filter, because the rest is bound up in the biofouling, right? So if what we try to achieve is with AFM, we are releasing 98% of the dirt that we catch in the filter. We release that because it's not being held in by the biofouling, which AFM doesn't allow it to do. Okay, so we'll talk a little bit more about that later on too in detail. So we are in all aspects of water treatment, not only aquariums and aquaculture. We are drinking water, we're desalination, wastewater treatment for big industrial plants, and many, many swimming pools around the world as well. We really are the sustainable choice to choose. I hope the sound plays on this. It's a quick video to show you how we produce AFM. If there's no sound, the sound is, it's just music. I can't remember if I clicked on allow sound when I joined. So let's start the video. Is there sound? No, sorry guys, it's just music. You can read what it says on the captions. But this is how the glass comes into our factory. Okay, all recycled, and that's how it leaves the factory. Pretty much fully on solar capacity. We've got a much bigger battery than that now. That's the old battery system. We only use rainwater for cleaning our media as well. So in a way, we are pretty much a recycling plant, because we also remove all of the contaminants from the glass and resell that on. So all the ferric metals, all the aluminium metals, paper, sludge, even to the sludge, it all gets resold. It's using our AFM for our own filtration, which we recycle the cleaning water continuously until it's no longer usable for cleaning. These are the most advanced color sorters in the world. This is where we remove the clear glass. We don't want the clear glass because clear glass doesn't have the metal oxides in it to be able to go through the activation process. Okay, so if someone's trying to sell you clear glass and says it's activated, there's a better word for it, but I'll say it's nonsense. This is the activation process. So it's 3-step chemical and thermal activation process. And of course, if you guys are ever in the area of Scotland or Switzerland, where our 2 factories are, you're welcome to have a tour of the factory. We do many tours at our different factories. So I'll talk a little bit more about the different types of AFM. The plant is pretty much fully automated. At a push, we can run the plant with only 3 people. On a daily basis, there's 5 people running the plant, but at a push, we can run it with 3 people. That includes loading the trucks outside. Okay. So why does the AFM work so well? It's because we don't allow the biofilms and no place for breeding of pathogens, because the biofilms are the perfect place for breeding of parasites, viruses, amoebas, all sorts of pathogens in there. Then there's no clustering, like I said earlier on, making sure that our filtration remains consistent throughout the life of the filter vessel, actually, because our AFM media never needs to be replaced. So generally, the filter vessels need to be replaced before our AFM media does. In different applications, like in swimming pools, but for particularly for marine mammal systems, because we filter so well, we reduce the trichloramines, which are the harmful gases for dolphins that burn their eyes, or seals that damage their lungs. It can even penetrate through the skin. The trichloramethanes can penetrate the skins. It's bad for the animals. So by filtering out so much more of the organics than normal sand does, we dramatically reduce the problems of trichloramethanes and trichloramines in the systems. So it's all a stable and reliable filtration performance. We have the 2 AFM products since 2020. So we've been making AFM for nearly 30 years now. The AFM Standard was our original product that was produced in Scotland in our factory there, designed by Dr. Howard Dryden, who initially was Dryden Aqua used to be Dryden Aquaculture. We used to be a distributor for the aquaculture segment, and Howard came up with AFM because he was also doing a lot of work with mammal systems, dolphin systems, and to help reduce this trichloromethane and trihalomethane problem. That's how he came up with the AFM. He tried activating sand. He tried active carbon. He tried zeolites. He tried a whole range of different medias, and then he tried glass, and he was able to activate the glass, like I said, with the metal oxides inside them. He was able to activate that. So our AFM standard has got a high negative charge on it. So if you take any green and brown glass, it will have a negative charge on it. In part of our activation process is we dramatically increase the surface area on the grass with flash heating and cooling, which microfractures the outside surface of the glass. By microfracturing the outside surface of the glass, we're increasing the surface area and therefore increasing the charge density. So our negative charge is generally 4 times higher than you would measure on a normal piece of green or brown glass. Okay. Then our other product that we've been producing since we started the factory in Switzerland in 2020 is our AFM NG. The NG stands for New Generation. This is a product that has a hydrophobic coating on it. It's baked into the glass, so it doesn't wear off over time. And why do we want it to be hydrophobic? Of course, because anything that's hydrophobic generally floats in water, right? So there's a slightly different installation process for doing the AFM NG. And the reason why we wanted hydrophobic is because most organics, lipids, fats, microplastics, they all have a tail segment on their molecule that is hydrophobic. And that's why oils rise to the surface in water and then end up combining together. Those tails end up adhering to the AFM NG. Okay, so we're using 2 different principles with our 2 different medias. The AFM standard is using the high negative charge for the adhesion of small particles, not absorption, that's carbon. Adhesion, so it sticks to the outside with the high negative charge, and then that mild charge is broken off during the backwash. With the hydrophobic AFM, AFM NG, we're using the hydrophobicity around the surface of the AFM, where that hydrophobic tail of the particles sticks to the AFM. And again, that is broken off during the backwash process because it's a mild bonding that's mild enough to hold on to the AFM in the filtration processes, but not strong enough to hold on during the backwashing processes. There are some applications in the oil and gas industry where we don't use the AFM NG because the bond is too strong for that particular fat, and it's mostly the fats that cause problems, and then that bond is too strong and it needs chemical or thermal cleaning of the AFM. So in some applications we actually still use the AFM standard in oil and gas, even though we're trying to remove oils, because that bond is too strong, right? So just to show you quickly the difference, this is a video. Yes, great. The top one is the AFM standard. You can see how it absorbs the water. So because of the negative charge, it pulls the water into the media. And then the AFM NG at the bottom just pushes the water away. Okay, because of its hydrophobicity. And that's why it needs a slightly different installation method, and it needs a soaking period. So what ends up happening is because of the NG, the hydrophobicity, it holds onto a lot of air. That either needs a 24-hour soaking period for the excess air to be released off the AFM, or because our media is so clean, quite often we just tell the client to put it straight into filtration mode for 24 hours before you backwash it. If you do it normal like sand, you would install sand and then you would backwash it first, you will lose a lot of your media because of the media that's floating. A lot of the media will be floating initially. So it's got a slightly different installation capacity. In other applications that not animals, aquariums or aquaculture, we actually put in a drop of dishwashing liquid, and that breaks the surface tension, allows the media to settle very quickly, and then they can put it straight into filtration mode or backwash it. But aquariums and aquaculture, most people don't want to add drops of dishwashing liquid into their filters. All right. So if we have a look at filtration performance, the red line with the, call it 95% filtration efficiency down to 1 micron is our AFM NG grade 1. The small, can you see my mouse cursor? No? Okay, let me just put the highlighter on. Laser pointer. Okay, so the small green segment is our AFM grade 0, which is our very finest media. It's not a media that we use often anymore because it used to be the media that we would use to filter down to 1 micron. But now, since the AFM NG filters down to 1 micron at 20 meters per hour, we're using that instead of AFM grade 0, which filters down to 1 micron. But because it's so fine, it really is only effective at 10 meters per hour filtration velocity and less. And of course, most applications want much higher filtration velocities. We still use the grade 0 in lab situations. So any commercial lab or some research facilities, we still use the grade 0, but mostly we've shifted to the NG grade 1. Then the green line is our AFM standard grade 1. So here you can see we achieve 4 microns filtration performance at 95% efficiency. The next best media is actually a sand media out of Germany. And believe me, we've tested media from around the world, right? So yeah, you can see the sand media out of Germany that is doing the best. Of course, this is all brand new media. As soon as these start to become biofoul, then this performance also, it increases initially, but then starts to drop off and have intermittent fouling. Then all of the other medias below this are glass medias, other glass medias, competitive glass medias. And I can say we've tested, I think, nearly every glass media from around the world. So, and sand medias from around the world, but I'll get to that shortly. So here we're talking about bed expansion and what's important, right? So there's two things about backwash. It's bed expansion and fluidization, right? So bed expansion is there to open the media to allow space to let the dirt come out. Fluidization is also to make sure that the media at the bottom is coming up to the top to allow the dirt to come out as well. If you only get bed expansion, you're not getting as efficient backwash as you can. Okay, so you need bed expansion and fluidization. So here you can see the green line is our AFM NG. You can see we achieved 20% bed expansion at around about 28 meters per hour. Then another of our cheaper glass products, but it's not activated in any way, that's around about 30 meters per hour. Then you can see Certicon, this is a glass media as well. Astral glass media, I mean, this NatureWorks glass media, it only achieves 20% backwash at around about 68 meters per hour. And then the Astral is the worst of the lot at around about 75 meters per hour needed to get 20% bed expansion. So two things, if you look at our documentation, we always recommend 40 meters per hour backwash velocity. Why is that? If we get bed expansion at 28 meters per hour, it's because in most applications, your organics, once they combine in your filter, become heavier than what 28 meters per hour can deal with to lift those organics out of the filter. So what ends up happening if you're not backwashing at the 40 meters per hour, you might be getting fluidization and bed expansion, but your organics are too heavy to be lifted out of the filter, so they end up sitting on top of your filter bed, right? They go up into the water column, they don't really release, and then every time you come back into filtration mode, over time, your pressure differential increases over time. That's straight away an indication that your organics are heavier than what your backwash velocity currently is. Okay, so you should increase your backwash velocity. Our general experience is 40 meters per hour will release all organics. Okay. If you are doing intake systems, either groundwater intake systems or some seawater intake systems with heavy metal contamination, we would always recommend a backwash velocity of 50 meters per hour. Again, our experience is that 50 meters per hour is what's required to lift the heavy metal particles out of the filter during your backwash process. This, I think, yeah. here's a video of the Astral glass media. Sorry, I should have started that already. You can see here it starts at 1 meter bed depth. We are backwashing it from 0 to 60 meters per hour. And you can see the very slow expansion of the media as we are ramping it up. And at 60 meters per hour, it only achieves the 10% bed expansion. So the German DIN standard, while this video is going, the German DIN standard recommends 15% bed expansion, okay, as a general. Again, we recommend 20% bed expansion because of our experience in many different applications from around the world. We recommend 20% bed expansion. By doing that, you'll ensure that your filter is totally clean. All right. Backwash turbidity curves. So again, we test everything. We use a test dust in all testing. We use a internationally renowned test method when we're testing our own filter media and all other filter medias at the same time. Here you can see we did a turbidity test of backwash at 40 meters per hour. This is the German sand. This is the particles being released at 40 meters per hour. You can see it has a small spike and then tapers down. This is a UK sand, which was terrible. And then this is our AFM. Okay, you can see how it releases all of the dirt because we're not holding onto it in any way. It's released. This is against other glass medias. So yeah, you can see the glass medias, brand new glass medias, were better at releasing dirt. This is 30 meters per hour. Unfortunately, our meter at this point it doesn't peter out, but the max was 950. We now have a 2000 NTU turbidity meter, so it shows way bigger spikes. But the important thing here is at 30 meters per hour to show you what we're talking about. And then if we ramp that up, so here at the end of the day, it petered out to be releasing no more dirt. We then ramped it up to 60 meters per hour. You can see the AFM stayed flatline, so it wasn't releasing any more dirt because it released it all in the beginning. Whereas the other medias, the Certican and Nature Works, still had a very big spike of media of dirt release on the second backwash, or not on the second, when we speeded it up to 60 meters per hour. This directly speaks to water savings. Okay, so because we can backwash, and again, this is at 60 meters per hour compared to 30 meters per hour. Here you can see we saved 67% of water compared to the Certican, 37% compared to Nature Works at 30 meters per hour. Then if we at 60 meters per hour, we actually saved even more against ourselves. So 2,415 liters per square meter compared to 1,730 30 liters per square meter of water being used. So the faster you backwash, the less water you actually need to use during your backwash process. Okay. And then again, compared to Nature Works, we were 77%, 48% against Certican and Astral. Why is that? So why do these other medias not expand, these other glass medias not expand and release the dirt nearly as well as we do? It's because we engineer the shape of our media to be pretty much perfect. The only other media that is better at backwash than us is the glass beads. So why? Because the glass beads are perfectly round. They have the perfect surface area to expand and release. So they are the best at backwash, but the worst at filtration performance, as you remember seeing from our graph initially. Filtration performance is the worst, but they're the best at backwash. Okay. Our media, the shape of our media has been designed for backwash processes, not only for filtration processes, whereas all the other medias, because they use a hard crushing technique, you'll see if you hold their media in your hand, you'll see a lot of sharp shards and flat pieces of glass. you can imagine when those go into backwash modes, those flat pieces and sharp shards just stand upright in the water column and actually end up dropping down in your filter bed. And over time, that is also what creates a increase in filtration pressure over time, because those flat pieces and sharp shards end up at the bottom of your filter, blocking up your filter. So not only the dirt that's not being released, but the glass itself is also creating problems for you. Aquariums and zoos around the world, we at over 200 now. Some of these are too small to put numbers into them, but here's some numbers on the side. We have many aquariums and zoos around the world. I don't have a number of aquaculture facilities, but I'm working on that now with our distributors to give us lists. So I'll be hitting up ACS to say how many aquaculture facilities have you supplied AFM to, but you can see that we're well represented around the world with AFM. Some case studies. Are you guys mostly aquaculture? By the look of you, you guys are mostly aquaculture, right? Not really aquariums. So I can jump past the aquarium stuff. I thought it was a mixed batch, but yeah, we in all the big aquarium brands around the world, from Sea Life, Sea Worlds, Landry's aquariums, yeah, all aquariums around the world. But I'll jump through that quickly if you mostly aquaculture guys. Intake seawater systems. We are huge on intake seawater systems for aquaculture because of our filtration down to 1 microns. We have many large shrimp farms on seawater intake systems with AFM. Also down in Tasmania, we have intake seawater systems. I don't know how many acts you guys, I know that we've done a few intake seawater systems with you guys at research and things like that, but Norway, also Kingfish Netherlands uses our media for both their seawater intake systems and their hatchery systems. The Kingfish Maine is also going to be using. So we generally, seawater intake systems is where we have historically always performed in aquaculture, right? When it comes to seawater intakes and heavy metals, we have a slightly different process, but we'll go through. If you have those kind of problems, let me know and we'll go through that with you. I'm just showing you some examples of what we do with the different systems. Then with the fish systems, this is aquariums particularly, recirculation systems, what we recommend. So we have far less biological load in the systems, lower ammonia levels, reduced biological filtration, surface area required, which speaks to you guys, but I'm going to jump through these now because you're not aquarium people. Very big impact on marine mammal systems, coral systems, because we totally inert, so we're not we can be used with coral systems as well. We use by most of the coral regenerative companies, so that are growing corals to replant them all around the world. Most of them use our media for the seawater intake and recirculation systems. Okay. Then if we talk about aquaculture systems, which now becomes more important for you, the shrimp hatcheries in Vietnam, the biggest hatchery in the world, VetUC, uses our media and our air diffusers actually for their intake systems, because they had very big problems with their intake systems. There's a case study on the right-hand side where we can show that we removed norovirus from seawater intake systems because we filter so well and we don't allow for the continuous breeding of the virus within the biofouling of our media. We reduce their UV requirements, all of that. So these are all case studies we're happy to share with you. If you ever need, just let us know and we can share that with you and go through it. So in RAS applications, incoming water, of course, RAS wastewater treatment. So quite often, because of the regulations around the world becoming very stringent on wastewater treatment out of RAS applications, we are the last line in defense of the water being released into the environment. So generally what we are seeing growing very quickly now is drum filtration on the wastewater. So all backwash water or wastewater, it goes through drum filtration, then it's going through coagulation, flocculation, and then a belt a belt filter to remove all of those organics, and then that water after the belt filter is being filtered by AFM to be released into the environment. Okay. Where that water is at that stage, we also then can recommend going in through a biological process to remove the nitrates out of that water before it's released. So quite often it will go into settling ponds with our air diffusers, so that the water has a slow method before it is released out into the environment, with our air diffusers creating a high biological and healthy environment to reduce the nitrates out of the system. Well, to make sure that all of the ammonia nitrites are converted to nitrates, and then further down the line there would be planted areas to absorb the nitrates before it's released into the local river or wherever it's going. Okay. Hatchery systems, we work in hatchery systems from 100% filtration with AFM all the way down to 20% filtration of AFM. So what they are doing there is very dependent on their turnover rates, and we very much accept that quite often aquaculture, because of the very high turnover rates that you have in aquaculture, 100% of AFM filtration is not always feasible. But what in many farms, because they're identifying now that the fines in the water is just as problematic as the large particles, right? So you're using drum filters to remove particles down to 30 microns, and quite often protein skimmers to remove the particles from 5 microns and lower. But there's that gap between 30 microns and 5 microns that is not being dealt with. Those particles are ending up on your biological filters. Your biological filters are then becoming filters first before they become biologically active, right? So your bacterial regime is moved towards the heterotrophs rather than the autotrophs, which the autotrophs is what you want to convert your ammonia to nitrates. You don't want so many heterotrophs in your system converting the organics to ammonia first, then to the autotrophs to get to nitrates, because that just needs a much larger biological surface area, right? So by using the AFM as an intermediary step to remove more of the fine particles, you can dramatically increase the efficiency of your biological filters. Or if brought in right from day one, you can have a much smaller biological surface area than what has generally been required previously. Okay. So that's the side loop filtration that is happening in hatcheries, and even to some extent, we're doing trials now on grow-out RAS, having AFM side loop filtration on grow-out RAS as well. Okay. We also, as you can see on the right-hand side, our air diffusers are also used a lot in aquaculture, from helping to keep sea pens, the grow-out sea pens clean, because they'll put the air diffusers around the sea pens to help aerate the outside surface to keep seals away, keeping it clean, and also creating a very good aerated environment for the fish in the sea pens, to having the diffusers on the floor below the sea pens to keep from the area becoming too settled with organic waste under the sea pens. It's even to that extent. Okay. Also used for CO2 degassing and aeration of biofilters. All right. Again, same application for aquaculture intake systems as before, both for organics and heavy metal removal. We can do it all. This is very quickly, of course, there are many different design concepts out there. This is just one of the possible design concepts that is out there. This is pretty much a standard one. Which we would then add AFM and a circulation. This is the hatchery culture larval rearing, because of course that's where you want your water to be the most, the cleanest. So Kingfish Netherlands uses a dual AFM filtration. They use our AFM filtration in their seawater intake systems, and then all water going to their larval rearing and hatchery systems is filtered again through AFM. Okay, so if we look at how AFM works, because AFM uses a lot of adhesion for pulling out the fines, the first stage of AFM generally deals with all of the large particles and some of the fines. The second stage of AFM, running at a slower velocity, is really focusing on removing fine particles even into the submicron range. You will, on those second stage filters, if you do it in this way, just so that you're aware, you will never see a pressure increase on your second stage filters, because all the larger particles have already been dealt with in your first filtration. So if you don't backwash those filters, what you'll see is over time, you'll start seeing fines penetrating, because there's no more surface area on our media to absorb the fine particles. So once the media surface in that whole filter has fully accumulated with fine particles, there's no more space for those fines to be removed, so they will start penetrating through the bed. Depending on the time of year, if it's in summer and you have algal periods, you might need to backwash more frequently. So like Kingfish is now backwashing once a week for that period, and they have no problems with that. And then during the winter months, they're backwashing every 2 to 3 weeks, and they're finding that they're not having fines penetration. Initially, they had after a couple of months, they started having fines penetration through the second batch of filtration, and that was because they just didn't backwash, because they didn't see any pressure differential increase, so they thought they didn't need to backwash. As soon as they started backwashing on a periodic regime, their fines penetration problem went away. Okay, it's adsorption. You must remember that. We are working with adsorption. All right. Aquaculture side loop, different ways you can do it. This is 100% aquaculture. This is a side loop filtration. So in Turkey, we have a hatchery in Turkey where we have 3 different systems running. We have one system worked as a standard system with only drum filters, protein skimmers, and MBBRs. And then we have another one working exactly like this with the AFM side loop filtration, and then we have another one working without the drum filter, only AFM filtration, protein skimmer, and MBBR. The hatchery manager says that what he's finding is that the system with the drum filter is actually needing to backwash the AFM more often than the filter without the drum filter, than the system without the drum filter. Why is that? Because quite often the plant operators are running the drum filters with too higher pressure differentials, which means that the fine organics are being squeezed through the mesh of the drum filter. Because I can tell you in salmon farms in Scotland, the organic load is so soft there, it very easily gets squeezed through the mesh. So they've got their drum filters need to pretty much be washing down continuously to prevent that from happening, but even still, they get some penetration. So in this application, it was a sea bream. The hatchery was growing sea bream. They found that if they didn't have a drum filter, their backwash process on the AFM was actually longer. So there was a longer period that they could run without needing to backwash, and their water quality was actually better. All right, just as an application. Then grow out systems. Again, this is a concept. If we are moving towards more and more 100% recycling, you'll see some of these systems coming out on LinkedIn now. People are starting to talk about 100% recycling, very little waste of water, using denitrification processes, whether it's sulfur denitrification or methanol denitrification. But guys are starting to use these processes, which we use a lot in aquariums, because there are many inland aquariums that need to use denitrification processes. And aquaculture is just slowly starting to incorporate these into the systems. So this is, again, a concept that we coming from our experience both in aquariums and aquaculture, we would say this concept would work very well using the AFM filtration media, because the last thing you want to do is have any organic load in your denitrification system. That it just compromises the denitrification system and creates problems for pH and the possible release of H2S into your system. Okay, so that's, and again, whether you use oxygen concentrators by nanobubbles or Venturi systems or Spice cones or whatever it is, those will always be required, right? Okay. This is the wastewater system I was talking about. In this wastewater system, we actually recycle the water through the AFM and UV sterilization to use it for all cleaning processes. So the wash down of the drum filters, the wash down of your floor areas, all of that you can reuse some of your wastewater from that, and the excess can go out either, as I said, biological treatment through pond systems, or you can sterilize it using ozone on the outlet system going out. Okay, this does need coagulation flocculation for this system. So generally this water is not reused for the fish systems again. However, there are now some organic coagulation flocculation products coming into the market that will enable aquaculture systems to reuse this water again in their fish systems. All right. So very interesting. And then in many of these systems that we're seeing an increase in pyrolysis. In other words, the sludge that's being removed out of these belt filters goes to a pyrolysis process, creating biochar, which can then actually be a sales product for the farm, because you can sell it as a high efficiency organic fertilizer, right? It's a slow release organic fertilizer that can be used by farms. So the fertilization is not there's no runoff from the fertilization process as you would have from spray fertilizations or the standard or organic fertilizations. With biochar, it embeds into your soils, and it's a slow release nutrient loading. So it's a very good one. There's been a lot of research, because I presume a lot of you guys are seawater facilities as well. So there's also been a lot of research about the amount of salt in that biochar and how that can contaminate the beds during fertilization, but it's been shown that actually a lot of that salt is required by plants. So it's not such a high loading of salt that it's negatively affecting the growing processes on farmlands. It's actually being used up by the plants quite effectively. That is new research, so that is still going to take time to process through, but these are all the different opportunities. Okay. So finally, you can please follow us on LinkedIn, and also we have a aquarium and aquaculture YouTube channel, which you can do. We've got all of our information is on our downloads page, drydenaqua.com downloads. Here's our aquarium and zoo webinars series, but also it's also the same channel that we'll do aquaculture. Right now, I'll admit we don't have as much aquaculture content on there at the moment, but we are intending this year to put a lot more focus into aquaculture webinars to discuss design philosophies. All of the content on there about AFM filtration is obviously relevant to you guys as well, but this is too. All right. So I'll stop the presentation. So for the question, unless there's, sorry, was there any graphics you wanted me to jump back to in your questions? Anybody wanted me to jump back to a particular slide for the question and answer session? Sorry, I know I went through that pretty quickly, but I hope that it was slow enough to highlight some points for you, and we can go from there. Okay, then I'll stop. Hi.
We've got
Mike,
Scott here.
can you hear me?
With a question.
Yeah,
Yeah,
Scott, hi,
sorry.
I got you.
Appreciate the time. I just was interested on one of your slides about intake systems, Mike,
Yes.
and a question I came up on was about the backwash turbidity requirements. In our particular situations, we'd be dealing with heavy metals and
Yeah.
potentially abstracting water during high turbidity when the ambient water is in high turbid mode.
Yeah.
Do you have any recommendations on the backwashing systems aside from just high flow rates or uh,
Yeah. So generally seawater intake systems, I always recommend because of the variability of the loads. So either during storm surges or during algal event, you might have high TSS loads greater than 20 milligrams per liter, right? So in those situations, I always recommend putting a thin layer of anthracite, not activated carbon, anthracite, on top of the AFM, because what the anthracite then does is it acts as a pre-filtration for the larger particles on top of the AFM, because if those larger particles come down into the AFM, they what's called blinding the surface of the media. Any surface can be blinded by large particles, right? So the anthracite removes those larger particles and leaves the AFM to filter the fines. That's algae, or during surge events, like I said, that can extend your run phase during these events by up to 6 times the standard run phase, right? We have calculators. I can show you our calculator as well, which will give you a good indication of your run period, depending on your TSS incoming levels. If your TSS is greater than 50 milligrams per liter, so TSS is total suspended solids, just to make sure. If your TSS is greater than 50 milligrams per liter, depending on your flow of your incoming flow rates, we would recommend a pre-filtration step, whether it's screen filters, depending on what's coming into your system, or cyclone filters, which I know we've used quite a few times with Fresh by Design on intake systems as well, that have the heavier particles, sand and things like that. Those also work very well. And then what we also quite often recommend is a oxidation step, right? If we, particularly for heavy metals, because your heavy metals, when they're in solution, AFM cannot filter anything that's in solution. So we consider anything that's in solution is sub 1 micron. So anything less than 1 micron, we cannot filter it out. We consider it as in solution. In many situations, we use ozone in a very low dose, so 0.2 milligrams per liter dosage. That's a flocculation dose, which helps to flocculate particles. It also helps to increase the zeta potential of the water. In other words, changing the charge density on particles. Quite often, if your particles are fine, they're all very similarly charged, either very high negative charge or high positive charge. They won't bind together because they're similarly charged. When we do a oxidation step with ozone, that helps to neutralize that charge, helps to combine the particles together for better removal. But of course, in periods of algal events, that will also help to break down algal cells and then flocculate those cells. So ozone is one of those processes for also oxidizing heavy metals. However, more often than not, what we recommend for heavy metal removal is just using our air diffuser. It's the easiest way of oxidizing the heavy metals, depending on the heavy metal you're trying to remove. So if it's mostly ferric or iron, that settles out or oxidizes very quickly with air. So it can be anywhere from 5 to 10 minutes residual time in a sump. Or if it's arsenic, then generally it needs up to 30 minutes for those arsenic and manganese molecules to grow to a size greater than 1 micron for the AFM to remove. And then we deal with a whole lot of other heavy metals as well. Did that answer your question?
Yeah, you're plentiful. Thank you very much.
Great. And then
That's
just to
right.
cover the backwash, when we're doing heavy metals, as I said before, we always recommend at least 50 meters per hour backwash velocity. So 50 meters cubic meters per hour per square meter, because that's what's needed to remove those heavy metal particles out of the filter. If you
Okay.
don't, over time, it will build up in your filter. And then AFM will never channel down the middle of the filter, but if your filter becomes totally saturated by particles because of an inefficient backwash process, what will end up happening is that you'll see that the water will start going down the side of the filter. Okay, that's very easy to see. If you open your filter, you look down the edges of your filter, and you'll see it dips down at the edge. That's straight away an indication that your filter hasn't been backwashed correctly. Either it's a very poor filter design. Please have a look at our webinar series on filter design. We can send out links later to all of our different things, because that's very important. Unfortunately, in many aquaculture applications, swimming pool filters are being used for aquaculture. Aquaculture is very high load applications. Swimming pool filters are not designed for high load applications. What tends to happen is, because their lateral designs are very poor, is that it won't create bed expansion. It creates boiling directly above your laterals, and that does not clean the full bed of the filter. That means you only clean above your laterals. When you go back into filtration, because the area above your laterals are clean, those are the only areas that start to filter, which means that you think you're filtering at 20 meters per hour, but I've seen examples where those filters are filtering at 50 plus meters per hour, and fine organics, soft organics, you cannot remove at those high velocities. Okay, so please have a watch our webinar on filter design. It's very insightful. I'm really trying to spread that information to both aquariums, zoos, and aquaculture facilities, because unfortunately there's still a misconception that any filter vessel works in any application, and that's really not true at all. The Fresh by Design guys, I've gone through this in detail with them, and that's why they've now really started to use filters that we are recommending that are better than the standard swimming pool filters you can get out there. All right.
Sweet. Does anyone have anything else? Any other questions?
Okay. Filtration, media filtration is very much like a computer, right? You've got your hardware component, which is your filter vessel. You've got your software component, which is your media inside that filter. If you have a very high quality hardware computer with crappy software, it's not going to work very well. If you have a poor quality hardware and high quality software, again, it's not going to work very well. So to achieve the best filtration performance, and that's what you guys are aiming for, make sure you've got good quality hardware and good quality software. All right.
Wonderful. If oh, we've got a question from Andrew. Can you use where did I go? It's in the chat. Andrew wants to know if you can use both types of media together or in separate filters.
Yes, you can actually. In applications like I have in South Africa, we've got a lot of groundwater applications where they have both high organic load because of sewage contamination and also heavy metals. Africa's got a lot of heavy metals in the ground. So then we can mix the two. So you'll have the AFM standard and the AFM NG in the same filter vessel together, focusing on both parts. So yes, that is very, very possible. And we do that quite a bit in Africa. We also have our AFM DIN, which is it's a grade, filtration grade between grade 1 and grade 2. which we originally made the AFM DIN to comply with German DIN standards so that we could sell our media in Germany. However, in testing and in application, we've actually seen that it's an incredibly good media. One of the really good points about it is it still filters, even though it's larger grain size, it filters down to 4 microns. So the same as our AFM standard grade 1, it filters down to 4 microns, but it has up to 8 times the holding capacity of our grade 1 media. So in other words, it can run for 8 times longer than the grade 1. So in terms of, unless you really need, if you've got a lot of pathogen problems, most pathogens sit in the range between 4 and 1 microns, their particle size. So if you don't have those problems in your incoming seawater, we are moving towards recommending our AFM DIN in seawater intake applications, because it's got that much higher loading capacity. So when you have the storm surges or you have the algal tide events, it can last a lot longer than a standard media would last.
Sweet. Thanks for that. Anything else before we close off the session?
If you guys have any questions, technical questions, please, Axel will happily share my details, and you are more than welcome to contact me directly for any applications. Of course, everything, please copy in Fresh by Design guys so that they're aware of the discussions, and it's also helpful for their learning as well. And in those ways, the more questions we have, the more we all learn together, right? Believe me, I still learn on a daily basis because we're working in so many different applications. So it's really great to have questions that we need to answer to.
And if you guys have any questions and like if we're unable to answer it straight away, we'll go straight back to Mike and Dryden, and we'll be able to get those answers for you as well pretty quickly. So yeah, please don't hesitate.
Yeah. So I saw a question pop up there. It went away very quickly, but it looked like can DIN be used as a pre-filtration? Was that right?
Yeah.
Yeah, yes, definitely. The DIN can be used as a pre-filtration step to the AFM NG grade 1, so that you get the best of both worlds, both high loading capacity and 1 micron filtration. Just remember that although in many places around the world, AFM is starting to replace UF filtration, because we can filter down to the point where we can achieve many governmental requirements for the reuse of wastewater without having to use UF. Any media filtration is not barrier filtration, it's percentage removal. Okay, so it's barrier filtration like UF or cartridges is 100% removal until it clogs, right? And then it needs to be cleaned. Any media filtration is a percentage removal, and that's why we always state 95% of particles at 20 meters per hour. If you go slower, we can, like in many water treatment applications where we're filtering at 15 meters per hour, we can achieve 98% of 1 micron particle removal, and even more at lower velocities. But again, it's a percentage removal because it's not barrier. It's not a barrier. Okay.